Good afternoon, everyone. I am Monish from AML department. I am going to present my video presentation for mini project title Exam Timetable and Seating Arrangement System. And I am guided by our mentor, Ravinder sir. Managing examination is educational institutional, involves in handling department, students, subjects, exams, and rooms in a structured manner. In many institutions, exam timetables and seating arrangement are still prepared manually and leading to increased workloads and pressures. Manual examination management can result in problems such as overlapping exam schedules and inefficient room utilization and improper student seating. With the growing student strength and multiple departments, the need for an automated centralized automation system is essential. The proposed and web-based system provides an admin collected platform for managing student data, room allocation, and seating arrangements efficiently. Exam timetable and seating arrangement management. The challenges. What are the challenges? Okay, time consuming, human errors, inefficient resource utilization, scalability issues, objectives. Time consuming. Traditional examination timetable preparation in seating arrangement are done manually, requiring significant time and effort from administrative staff. Manual scheduling can lead to errors such as exam clashes, duplicate seat allotments, and exceeding room capacity. Improper planning may result in utilized and overcrowded exam halls. Managing exams become increasingly difficult in growing number of students, departments and subjects. Objective to develop a web-based system that automates exam timetable and generation of a student seating arrangement. Scope of the project. Exam timetable and seating arrangement system has a scope of focusing on developing web-based system to manage and exam timetables and seating arrangement efficiently. Automated exam schedules, student allocation, and room management to reduce manual effort and errors. Ensure proper utilization of exam halls by collecting students based on room capacity. Provide an admin collected interface for managing students, departments, subjects, and exams and rooms. Target audience educational institutions, examination departments, and academic administrator. Deliverables. A function web application for an exam timetable and seating arrangement management. A functional seating allocation based on predefined constants. A user-friendly admin dashboard as secured access. Project documentation explaining system design, workflow, and implementation. It includes collection of management of students, departments, exams, and room data from the institutional organization. Okay, automated generation of exam timetables and based on predefined schedules. Automated seating arrangement considering room capacity and student allocation rules. Exclusion. No real-time data students attendance monitoring during examination. Only online examination or question paper distribution. No biometric or RFID based verification system. Not intended for result processing and evaluation management. It is not meant for any result and evaluation process. Data. The use of institutional data such as student details, department, subjects, exam, schedules, and room capacities provided by the administration. Pre-processing. Validate and organizing the input data to ensure consistency, avoid duplicate entries, and maintain correct mapping between students, exams, and rooms. Limitations. Data accuracy depends on correct manual entry by administrators. Scalability. System perform anyway, handling large number of students, exams, rooms without backend operation. Okay. Data processing, seating allocation, web application development, integration and testing are the levels of this creating the mini project. Exam timetable and seating arrangement system consist of integrating students, department, exam, and room data, defining examination rules and scheduling constraints, selecting appropriate exam halls based on the capacity, implementing automated seating allocation for logic, system design and implementation, collecting and organizing academic and explanation data, choosing suitable web technologies for system development, building a robust and scalable web application, stimulating different exam schedules and seating environments in the testing phase, analyzing system performance and allocation accuracy, implementing improvement of efficiency and usability of the project. It has a structural diagram flow. First admin, next authentication and authorized module, data management layers, student department subject rooms, database storage. One for exam schedule module, and second for exam seating allocation logic module. Next output is visualized to the end user. Architecture flow. First, admin logging interface. Admin access web application and logs using secure authentication. Authentication authorized the system validate the user credential and provide access only to the authorized users only. Okay. Data input and management. Admin enter manages related to students, department, subjects, and extracurricular activities capacities. Database management storage. All validated data is stored securely in the database for further processing. Exam schedule model. This system processes the exam related data to generate organized exam tables. Okay. Seating arrangement modules. Students are automatically allocated to the exam hall based on the room capacity and scheduling rules. It has following metrics and guidelines to seating allocation model, output and visualization. Generated exam timetable and seating arrangement are displayed on the admin dashboard for review and management system. Use case diagram. A use case diagram is a visual representation of the interaction between actors and the system. It shows the system boundary and the actors user set of use case and the communication between them. The use case of the model defines the external factors and internal case behaviors of the system. Actors, admin. The main user is responsible for managing all the examination data. Use case, managing students, manage department, manage subject, manage exams, manage student. He has to add, update, and delete student details. Manage departments. He has to add and update department details. Manage subjects. He has to add and assign subjects to the department and the required students. Manage exams. He has to schedule the exam based on the times and dates. Manage rooms. He has to add and manage exam hall based on the free and required rooms are available. Generating seating arrangement. Automatically allocated students to room based on capacity of exam schedules. Viewing timetable and seating plan. Review and visually generated timetables and seating charts. Here a clear flow chart of the exam timetable and seating arrangement system. First, the admin manage the students and then manage the departments and manage subjects and manage exams are generated as arrangement. Manage rooms and manage departments are get from the institution and the timetable seating plan is visualized to the end users. First, class diagram. A class is a representation of an object in the many ways. It simply has a template from which objects are created and classes from main building blocks of an object oriented application. It has an flow chart like sequence diagram like admin. First, login using username and password. Next, show dashboard. Next, manage student data. Add, update, delete the student data. Next, he has to manage the department data. Add and update the departments. Next, he has to manage subject. Add and assign the subjects to the departments and the students. Okay. Manage rooms. He has to add and update the room informations. Day-to-day do information observation real time. Generating seating arrangement. Allocating students to rooms. View timetable and seating plan. Display the timetable and the seating plan. Algorithm used. In this, the algorithm used are rule-based scheduling algorithm, greedy seeding algorithm, constraints-based allocation logic, rule-based scheduling algorithm used to generate exam timetables based on predefined rules such as exam dates, subjects, and department. Prevent exam clashes and ensuring proper scheduling. And know the same subject should be sit in an simultaneous in an predefined order. Greedy seating allocation algorithm assign students to exam hall sequentially based on room capacity. Ensure optimization utilization of available rooms without exceeding capacity. Constant based allocation system. Applies constants such as one student per seat, one exam per slot, and room capacity limits. It has to be followed strictly. Maintain a fairness and avoid duplication in seating arrangement. Sorting and mapping techniques used to organization students by department before exam allocation. Improve the efficiency and clarity in seating and distribution. Validation algorithm verifies the generated timetable and seating arrangement for conflicts and errors. Ensure the accuracy and reliability of the final output. Hardware and software selection. Hardware requirements. Personal computer, laptop, minimum 8 GB RAM is required. Okay. Internal i5 processor, AMD equivalent processor is required. Internet connection for deployment and seating allocation. Software requirements. For front-end, React.json and TypeScript is used. For styling and UI, Tailwind CSS and Shared CN UI and Radix UI are used. For routing, React Router DOM is used. For state management, for state management and data fetching, Tran Stack React Query is used. For form handling and validation, React Hook Form Zod is used for development and code quality. Wait, White and ESLint are used for database and storage, centralized database. For student exam, room seating data is used. For platform, web-based application browser schedule is used. The project is implemented as a web-based application for using modern front-end technologies. The system is developed using React JS with TypeScript for building modular, scalable user interfaces. White is used as the development tools to ensure fast compilation, optimize performance. Okay. Output website reference. In current work, the system generates exam timetables and seating arrangement based on the predefined rules and available data. In future, we have planned to incorporate additional concepts such as student preference, special coordination requirements, and dynamic exam scheduling. We also intend to integrate real-time notification and analytic institution data sources to enhance efficiency and support more insightful administrative decision making.